Hello, everyone. Can you guys hear me? Just checking the mic, sorry.
I can hear all right.
All right, thank you so much. So we are iStudy. So let's start. I am Angelica Flores. I am the project manager of the iGaze team for the iStudy project. And here today we have Jesus Garcia, who is our senior developer, Kavya Dayasani, who is our product manager in QE testing, and the rest of our members are Darenick, Cindy, and Mickey, who unfortunately were not able to make it today. With that said, let's get started. So what is iStudy? iStudy is an iOS mobile application designed for learning and special education by giving both teachers and students the ability to go through a daily online course without ever touching the screen. And you're probably wondering, how is that possible? Well, as you will see later on throughout this presentation, we will explain. But first, we must explain how we were able to get our work done. So we were using the Agile software methodology, which is a sprint, which we would use for 2 to 3 weeks. We would always meet up for at least 3 times a week, and we would meet up for 15 minutes. Of course, we always had to use project management tools such as Discord, Trello, GitHub, and all the Google G Suite. So why did we choose iStudy? iStudy was meant to be used for special education. We wanted to create a big impact during COVID, and we noticed that certain students who had motor disabilities needed to find a way to get online with us and work with us as an educator or student. We all knew we want to be very inclusive. So we wanted to target those who are in great need of software and that would allow them to never touch the screen because students with motor disabilities are not able to. So we wanted to integrate an eye calibration and an eye tracking software. With this, we created iStudy. iStudy was an application that integrates mini quizzes designed by teachers to help them and support them while we're able to maintain a very fun, interactive learning experience for students. So, of course, we also wanted to create heat maps that were meant for teachers to learn from their students and help them out understand what is it that they needed help with, certain questions after every quiz. We also wanted to make it free. We wanted to make it free because it would be accessible, portable, and we made it so that it would be for iOS smartphones and tablet devices. So what makes it so unique? Well, there is a market research, and other competitors such as Hawkeye and X Labs lack in certain aspects that we can fill in. iStudy is able to collect personal data. It's able to collect personal data to give a better user experience, is able to save data, and it's able to save data for no cost. So it's free. We have heat map integrations, which is something that our competitors already had. And of course, eye calibration. So why is iStudy still the best? iStudy is the best because it's accessible. We have made it so that students with motor disabilities can use it without ever touching the screen. It integrates the eye calibration and the pointer position so that our students or users, anyone who's using it, doesn't feel like they're being nauseous moving their eyes around the app, as well as smooth tracing, which is very important to us because most of our competitors were not able to have any smooth tracing. And of course, we're catered towards educational learning. And as always, this has been an iOS integration. So it would be for iOS smartphones, devices, and tablets. Our key mechanic overall for this course was having a stable eye pointer. A stable eye pointer meant that our students, our users, would be able to move their head around or maybe not even move their head around and look around the app without any fatigue or nauseous feelings, which of course were something that our competitors was not able to deliver. So the goal of our key mechanic is being able to use this function of a stable eye pointer so that the rest of our app would be easily navigable. So here we have our user case design. The user case design is just a simple roadmap of how the teachers and students interact in our app, as well as how our data is being saved. We also have the code-based design. And here you'll see that we were able to integrate AR Foundation for Unity by using their eye tracking and incorporate our own cursor so that we can create the main component, which is our software, and that would enable it to be used for students and teachers in the educational purpose, as well as collecting their data. So what can we do with our eye gaze data? Well, as you can see on our right, we have a heat map, and the heat map is created after every student finishes their questions. Depending on the time as well as where they're looking the most, it will create a heat map. And this heat map allows teachers to understand how students process each question, how much time and effort students are putting into each question, how effectively are they analyzing their own questions, and it's a great resource for teachers and students. Our user configuration is something that we were able to deliver, which is having a specific eye gaze registered and saved. So we can say it would be a save, set it and forget it. So once we noticed that our competitors were not able to save our eye gaze properly, it would always require us to log in again and register our eye gaze. We thought that was very annoying. And so we thought it was just a unique way that we can save their eye gaze data and set it and forget it. So that way they won't have to worry about it ever again. As well as users they have the ability to change the size of the pointer, which is very important because some students have difficulty seeing. And now we have how our app ties with data. Our app ties with data because depending on where a student is looking at the most, how many seconds, where exactly they're looking at, what picture, everything is being recorded, of course, with COPA regulations. So with that said, we will go on with how the data in our app is being stored. The data you can see was created with MySQL. And on the right, you will see that we have a users table and a heat map table. The users is saved with ID, username, password, last name, etc. Everything needed, as well as the heat map. It saves the user ID, the area of fixation, the total time, and the number of blinks. And this is all very crucial for our app. Moreover, on the data being collected. So every time a student or a teacher can log in, they would be required to log in securely by using a CAPTCHA login. And every time they log in, they would be able to verify their own code, as well as backing up our own database. We were able to encrypt our database using the algorithm of AES 128. Conclusions from our data. Well, as you notice, we have a very wide collection of data from every student and every teacher, but we're specifically geared towards learning about the student. So the student, we can pull up the information of who is the range of 8 through 17. And looking at their results, we can see that depending on their age, we can see how many times they were blinking, how much time they looked at a certain point. And based on this, we ourselves can comprehend that maybe the student is struggling if they're spending too much time on a certain question, or maybe they are not. More in details. So the conclusions from our data is easy to move on different sides of the screen. So it's easy for accessible for students with disabilities. The content is easily navigable. It fulfills the need for education catered to users with special needs. The use of powerful and vibrant colors, as you will see next, evokes the pleasure and joy for our students. So here's our demo. You will see now Kavya on our left. She will be calibrating her eyes. And as you can see, she is able to calibrate it again if she feels that the tracing is not smooth as she wants it to be, which is what you will see. She recalibrated and now she's able to continue with our application. And on our right, you will see how she navigated through our quiz, our mini quiz. So on the right here, you will see how after calibrating, she was prompted with this quiz question, and she can either choose true or false, and it would autocorrect itself. And as you can see, we will proceed with this question, and it would keep going until the very end. Next, we have the deliverables of all of our features that were asked of us throughout this course. So we were able to deliver collecting the username, the data, register safely for our users, and have users calibrate their eyes and saved only once. So that way they wouldn't have to worry about it ever again. And then they would have the ability for teachers to create mini quizzes. So that way students are able to answer the quizzes with their eye gaze, and the data would be collected into heat maps. And that way teachers can learn from these heat maps. The current status of our project is that iStudy is being built under Professor Chaha's IP. And it was shown that our shareholders, Smartbox, has seen it. So during COVID, we were low on staff, and we did not feel that we could have measured as much as we can, because the product isn't fully finished, but we have a good base so that our team can proceed and work from the ground up. And with that said, thank you so much. And now it's time for questions and answers. Thank you.
Hi, I'm curious about this pointer stabilization business. Is that software that you work to develop, or is that something off the shelf that you used? And is that a problem? I didn't quite understand if you improved it or you just used some existing solution for that.
Yes, I'd be happy to answer that. So we were using Unity, and Unity was used with AR Foundation, which allows us to use the eye tracking service for iPhones. But with the eye tracking service, we were able to create our own eye calibration, because the calibrating of the eyes was not as specific as we wanted it to be whenever we use the AR Foundation. So it was something that we were working towards, and just having the ability to have a smooth pointer was our main purpose of our project. Mhm.
Okay, but you don't have any objective measurement of what is a smooth pointer versus a jerky pointer. I mean, you just judge it by eye, right?
Yeah, we were mainly going by only our users, which was our families and friends. So some of our iOS friendly users were able to tell us the difference between our competitors' Hawkeye. I didn't like their eye pointer because I was too blurry for me. I couldn't look at it. And then they would have ours, which would be a little bit much more easier to look at. The pointer was bigger, and it was much more smoother to move around and track at the same time. So that would make
Okay,
a difference. Mhm.
that's great. I mean, that's something to brag about, that you improve this technology. Thank you.
Thank you.
Go for it.
I was going to say in the demo, it seemed like there was some drift going on. I don't know if she was attempting to answer the question true or false, but I kept sort of leaning my head over to the left. Was that intentional, or was that a side effect of the Unity eye tracking system?
Oh, well, in terms of our demo, it was mainly first the test run of whether we can move our eyes around. And then on the right of our demo, you would see how we navigated through our quiz. There was obviously, we weren't the best at calibrating this, but we were just managing as much as we could with the time. And even though it's not a fully finished product, we feel that this is a good base to move forward with.
Thanks.
I had a couple questions myself. So how much data is with the eye tracking? How much data is actually stored with that? Is that like a lot of data in a session, or is it like on the order of like kilobytes, megabytes? Like, what does that look like?
That is a very great question. We didn't have many users to work with, but it from what we gathered, I wouldn't be able to give you a full answer on the amount of space it took or anything like that. But we did have a fixed user database, unfortunately, and that's what we were working with.
In fact, related to that, so the user database was fairly small, but with the architecture that you have, how would you expect it to scale? Like how many users would you anticipate that this would be able to handle?
Oh yes. So we were able to start off with just being local. So we were using like a local database with our computer, but eventually we knew that we had to go global. So we think we at some point we were going to manage global, but unfortunately we didn't have enough time for it. So I wouldn't be able to give you as well the answer of how many users we can handle for right now.
Okay. Are there any last questions? Okay. If there aren't any more questions, let's thank the iStudy group one last time.